So x squared, what number is in front of x right now? 1, right? So this is 1x squared plus bx plus c. This is something, b and c are just the numbers, just regular numbers. So b is in the number in front of x, and then c is the constant at the end. So b is a coefficient. Typically, so this is the standard form for a quadratic, ax squared plus bx plus c. So you're going to hear me say we're factoring when a is 1 right now. So we are not factoring when there's a different number for a. Right now, a is 1, which makes our lives a lot easier. A is the number in front of x squared, b is the number in front of x, and c is the number at the end that's a constant. Sometimes you don't have c, which means that c is 0. So a, b, and c, we'll get familiar with that. Okay. So what does it mean to factor a polynomial? Well, here's how I'm going to write it. You're finding, I'm going to do this. We'll say break up the polynomial. This is what it means to factor. Ben, turn around. Into smaller pieces that obviously they need to multiply back to get you the original polynomial. This is helpful for graphing quadratics. This is helpful for finding x-intercepts. You do this a ton. It's helpful for simplifying expressions and things with fractions. You do this a lot in math. So this is one of the most important skills that you'll learn in this class. So here's how we're going to do this today. Since we have 1x squared plus bx plus c, the first thing we always do is we look for a GCF. We're going to factor it out. After you factor a GCF, I'm going to say since a equals 1, that's important because later on we're going to look when a is not 1, it's going to change things for us. So because a is 1, all we have to do is find two numbers that multiply to c and add to b. Is b?
8.
And so c would have to be what?
15.
15. So what I'm going to do, if this helps you, great. If not, that's okay. I'm going to draw this little like X out to the side. And I'm going to say that c is 15. That's what I have to multiply to. And b is 8. That's what I have to add to. So this is kind of fun because it's like a puzzle. You're figuring out two numbers that multiply to 15, but also add to 8. Figure it out. Talk about it. About Ellie, what are the two numbers?
3 and 5.
Bingo. 3 times 5 is 15. 3 plus 5 is 8. So here's how we do this. We are breaking this up, and typically when we factor, you're going to get two binomials. When it's a quadratic, that's what you're going to end up with. If you think about if you're multiplying these out, the first thing you need to multiply is x times x because you need to get x squared. We then fill in the blanks with what we just found, plus 3 and positive 5. So this is what it means to factor. This is like the most basic form of factoring besides factoring out a GCF, which there was not one here, which I skipped that accidentally. Here's what we should do right now. We should probably check it and make sure our answer is actually correct. So after you find those two numbers, and you've broken it up into two smaller binomials, we should probably multiply it out and check and see if it works. X times x is what? X squared. Okay. X times 5. Okay. 3 times x. Okay. Look at the board right now. Do you see where that adding to the b term comes from? Right there. They have to simplify and add together to get your original b term. And then 3 times 5. 15. There's the multiplying to c. We just saw it. So that simplifies to x squared plus 8x plus 15. Did we do it right?
Yeah.
Yeah. So check. But your final answer is this. It's awesome that you checked it, but I just want to make sure you understand that when I say to factor, I'm not saying, hey, put it in parentheses and I'll take it back out of parentheses. I'm saying put it in parentheses and leave it there. Let's write down our little x. Oh, that's not good. Here we go. We want two numbers that add to 11 and multiply to 24. Talk. 3 and 8. So we write it in two parentheses. Each parentheses has to start with r, because r times r is r squared. Then to finish out the parentheses, what should I put, Emma?
Plus 3 or plus 8.
Yep. It doesn't matter which order you put it, because either way, you should multiply out to get r squared plus 11r plus 24. We can check it real quick. I might just do it in my head. R squared, r times r is r squared. R times 8, 8r. 3 times r, 3r. So 8r plus 3r gives me 11r. So check. And then 3 times 8, 24. So that is good. So when you're factoring, there is no reason why you should get it incorrect, because you should be able to multiply it back out and check your answer right away. Do not come to me like, Miss Brent, is this right? I'll be like, I don't know, find out. Okay? We need two numbers that multiply to give us 24, but add to give us negative 11. Discuss. Negative 3, negative 8, because negative times a negative is a positive. Oh, whoops. So then whenever you break up into two binomials here, it would just be x minus 8, x minus 3. Are you getting the hang of this, guys? Okay, yeah, pretty simple. Next one, we are multiplying to 8, adding to negative 6. Figure it out, discuss. Finn, what two numbers are they? Bingo. So then it breaks up into y, pay attention to your variable. The variable might change on you. Y minus 4, the quantity times the quantity y minus 2. And again, you can check this, FOIL it out, double distribute, multiply each to each, whatever you'd like to call it, to see if you're correct. We're multiplying to what? 2 and adding to. That's a negative 1. You don't see a number, but the x is there. It's a negative 1. Okay, tell the person closest to you what are the two numbers that multiply to 2 and add to negative 1. So here's what we're going to say. Since there's nothing we can find, we're going to say it's prime. Just like a prime number doesn't have any factors, this doesn't have any factors. 15 is what we're adding to. No, it's not. Negative 15 is what we're multiplying to, and we're adding to 2. Tell the person closest to you what are the two numbers. 5, negative 3. So it'd be x plus 5, x minus 3. Yay. Next one. C's. It's got to add to negative 4. It's got to multiply to negative 2. So this is prime, though.
Whenever you have 2, it's hard.
Next, negative 36 is what we're multiplying to. 9 is what we're adding to. What is it? 12, negative 3. Let's write that as n plus 12 n minus 3. Okay. I know that the two parentheses still have to start with x because my first term is x squared. It's got to be x times x gives me x squared. Let's draw the little x to help us out. We are going to multiply to negative 55. We are going to add to what? 6. Ignore the variables for right now. I know they're a little bit different. So we need two numbers that multiply to negative 55, add to 6. Ben, what are they? Negative 5 and 11. Right, because 11 minus 5 is 6. That works. Now, let's go and put that in there. So minus 5 plus 11. As of right now, you could check it. Would these two binomials multiply to get you what you started with? Okay, then what could I add into those binomials to get it to multiply what we started with? Catherine, what do you think?
You have to add in y.
Where should I put the y's?
I think there's one y in each.
Okay, should I put the y with the x or should I put the y with the numbers?
The numbers.
Okay, yes, let's think about two parts of multiplying this thing out. The quickest way to check it. Here's your first numbers, right? X times x gives me x squared. This will be my last term. Whatever I multiply the last two numbers of the binomials, negative 5y plus 11y, will that give me negative 55y squared? Yes. Then I would go ahead and finish multiplying the entire thing out and check it afterwards and make sure that the entire thing works out. So let's go ahead and do that now. But it should work out. The first term and the last term is going okay. Then we should get the middle term because we already figured out two numbers that add to it. So x squared plus 11xy minus 5xy. I'm just multiplying it out. And then we already said that's negative 55y squared. Let's make sure that simplifies to what we started with. It does. So there's your strategy. I want you to try the last one on your own. So just checking, yes, it does work. So remember, your final answer is still this part here. What are my two numbers going to be? Luke, go ahead.
9 and negative 3. Oh.
Yeah.
Well,
So then it's going to be m plus 9n and m minus 3n.